Hi everyone, welcome back to Geeks for Geeks. Today we have another DSA mock interview, but before we start this mock interview, let me give you a quick introduction about myself. So my name is Yash Dwivedi. Currently, I'm working as a DSA mentor at Geeks for Geeks. I'm also a candidate master on Code Forces and a 5-star on Code Chef. So today we'll be interviewing Sarvesh, who is from IIT, and I'll be asking him 2 or 3 DSA questions in a span of 1 hour. So all of you can quickly just give me a +1 in the chat if my voice is clearly audible and the everything is working fine, so that we can start on time. And since we have just started, please give us a thumbs up to the video and hit the like button, uh, so that I can understand that okay, everything is working fine, and I'll invite the guest for today. So great. So let me invite Sarvesh to the screen. Hi Sarvesh, can you please
Hello.
introduce yourself to the audience?
So my complete name is Sarvesh Mukund Donga. I am from Mumbai, Maharashtra, and I am currently in the final year from IIT BHU Varanasi. My major is in chemical engineering. I have programming since my second year, and I am a specialist on code forces and a guardian on lead code. So my most projects are in web development, and coming to my certain interests, the mostly are playing badminton or learning or reading about history. So that is my introduction.
Okay. So, since you said that your major interest is in web development, so can you tell us a little bit about any of your projects, the best projects that you have made?
So the one project that I have mentioned in my resume is a Mun Stack application. It is basically a chat application which lets you chat with your friends or single chat or create group chats. In the group chat, you can add or delete a user. You can update either your data, or if you're an admin, you can remove somebody. So
So
these are certain applications.
basically every CRUD operations
Yes,
is
yes,
applied,
basically
and
yes.
you have a facility of making groups and other things in it as well.
Yes, yes, yes.
Okay. So as you know, first of all, are you excited for this mock interview or you're nervous?
Yes, I'm excited.
Okay. So how much you rate yourself on a scale of 10 in DSA?
I think 7.5.
Okay. So, as you know, today I'll be interviewing you, and the interview will last for 45 minutes to 1 hour, depends on how quickly you solve the problems. I'll be asking you 2 problems. The second problem will have a follow-up problem if you are able to solve the second problem within time. And if you are able to solve the second problem along with the follow-up, then I can ask you a third question as well, depending on the time. So, all the audience, everyone in the audience can give us a thumbs up to the video and give us a +1 so that we can start. So, Sarvesh, down there in the screen, you will see that you have a share option. So, can you please share your screen? If you will see, there is a share option. So,
Is the screen visible?
you'll get an option. Yeah, let me add it. Yeah, now it is visible. Perfect. So, I'll give you a question in the private chat. So, just quickly open the private chat, and you will see that there's a question, right? Great. So, you can open it now, and the audience can also start solving it side by side. So let's start off with this question. Okay, so let's quickly see this question first of all. So the have you ever played, first of all, have you ever played snake and ladder game in your childhood?
Yes.
Okay. So this question, in this question, what I'll give you is I'll give you a chessboard. I'll give you a snake and ladder board, and that will be of dimension 5 cross 6. Okay. So basically that means there will be 30 cells in the chessboard. Is this part clear? 30 cells will be there in the
Yes.
chessboard, starting from 1 to 30. So it's a one-based chessboard, one-based index chessboard, and the dimension is 5 cross 6. It will have 30 cells. What you have to do is you have to find the minimum number of dice throws. Okay, like you know that we throw a dice, and whatever number comes on the dice, according to that we take steps, right? So you have to tell in this question, you will be starting from the very first cell, that is the cell number 1, like cell with the index value is 1. You'll be starting from there, and you have to find the minimum number of dice throws in which you can reach the destination, or you can basically the destination is nothing but the last cell of the board, correct? That is nothing but the
Yes. Yes.
cell 30, cell with the value as 30, right? You can scroll down to see that, right? You can see that the cell with 30 value, you can scroll up now on, you can see the diagram there. So you can see that
Yes, yes.
30, like you will be starting from 1, and you will have to pass the hurdles and stuff, and you have to get in the minimum number of dice throws, you have to reach 30. Okay, that is the thing. Now in a, like, it's not a normal board, right? It's not a normal 5 cross 6 board. Like, what's the difference here? The difference is that you have snakes and you have ladders as well. So what will happen when you encounter snakes? When you encounter a snake at a let's say you throw a die and you reach a particular cell. Let's say if I see this diagram. So if you see 27, right? So you will see 27. So 27 is the topmost snake, right? So you'll see 27. At 27 I have a snake. So if I have a snake, then I'll reach one back, right? So that's a fall.
Mhm.
Okay, that I'll have. Similarly, if I'm at 21, so at 21 I'll encounter a snake. So when I encounter a snake, so I'll drop down to 9. Okay, that's the thing. Another thing is, let's say if you go to 20. So if you reach 20, then you will not stay at 20. You will go to 29, correct? Is that also clear to you?
Yes, yes, yes.
Okay. So these things are there. Now, how they will be given to you in data format. So if you will see, so like just scroll down a little bit more. Okay, but first of all, you can scroll up. I'll read the statement as well for you. So the statement, see, if the statement says that you will be given n, like you will be given an integer n. Okay, that will denote the total number of snakes and ladders. Okay, and you will be given an array which will be of size 2 cross n. Okay, where the index 2 cross 2i and 2i plus 1 will be a pair. Now what does that mean? So can you just quickly scroll a little bit down so that I can show it to the, everyone? Yeah. So if you will see that this test case, so if you see 3 comma 32 is given, right? So what is the n value? N value is 8. So the total number of snakes and the total number of ladders is 8, right? Combined total number of snakes and the total number of ladders overall is 8. And what is the size of this array? The size of the array is 2 cross n, that is 16. Now if you see, so you have been given a pair 3 comma 32. Okay, the first pair is, like, you can highlight it as well. You can see 3 and 32, right? The first two
It's
elements of the array is
22,
3
I
and
think.
32. Okay, yeah, 3
22.
and 22, sorry. So if you see 3, so from 3 you will get, like, you will go to 22 because there is a ladder. If you will see the diagram, so
Yes,
from
yes.
3 there's a ladder, so you will go to 22. If you will see 5 comma 8, so at 5 there is a ladder, so you will go to 22, like you will go to 8, sorry. Okay, then if you see 11, so at 11 there is a ladder, so you will land at 26. Can you scroll up in the diagram as well? At 11 there is a ladder, you will go to 26, right? Then if you see 20, so at 20 there is a at from 20 you will go to 29, correct? So you can see
Yes,
that in
yes.
the diagram as well. Yeah, from 20 you will go to 29. You can see the other cases as well. If you will see, so from 17 you are going to 4. Why? Because they will be a from 17 you are going to 4
Okay.
because there will be a snake. So you can
Okay, okay.
scroll up to see that from 17 you are going to this thing.
Okay, okay.
Where is it?
It's here. I think it is here. Here, this
Yes,
one.
17 you are going to 4 because there is a snake, right, like, right. Okay, now this is what you have to do. So every snake and ladder pair will be given to you indirectly in this array. So like
Okay.
you can see now, every I and I plus 1 pair will be there. Okay, so you
Yes,
have to
yes.
tell that in the minimum number of dice moves how you can like, what is the minimum number of dice that you have to throw so as that you reach the last cell. So is the question problem statement clearly
Oh,
clear
yes,
to
yes. It
you
is.
or not?
It is clear.
Okay, so you have any approaches? And if the audience is also clear to this question, so please give us a +1 in the chat. Okay, so what do you think? Like, how can we do this problem, Sarvesh?
Sir, the first approach that I think of is a Dijkstra algorithm. Basically, what I
Okay,
can do is insert in a priority queue the first element will be the minimum moves that the current number of moves that we have made, and the other two will be the current index of the cell that we are currently in. So from that cell, in one move, I can decide how much either I can go +1, +2, +3, so on to +6. And for every move, I will check that if it is possible to this move, and if it is possible, then the new cell which I will go through from that move, does it have a snake or a ladder? And if it does, then I accordingly redirect it to some another cell. Else, I will insert the cell that I will reach, and increment the current number of moves.
okay. So what will be the time complexity if you go for the Dijkstra approach?
It will be n log n, sir.
So is there any better approach that you can think of?
Mm, as in, where should I optimize in the time complexity part or
In terms of time,
okay, in terms of time?
you can think like whatever you are thinking. You can also tell us. Like you can share your thought processes.
Uh, so for in the starting cell, that when we have to check like six moves, you have to check right all the time. And
Like you will be just given the array, right? The array will be of size 2 cross n, and basically n like n pairs are there inside the array, right? So everything like the snake and ladder, like the ladder pair will be also given, and the snake pair will also be given to you, right? So those things will be given to you. You have to decide that what is the minimum number of throws of dice in which you can reach the final cell, that is the 30th cell.
so I think, sir, the Dijkstra will. I think that's the only thing that I think it is the optimum in this case.
Okay, any other thing
There
that you
is, I
can think
think,
of?
in the BFS, even BFS can work. I mean, for
Okay, how?
should I start to code, sir?
You can first of all explain the approach, like how BFS, what are you, why are you thinking about BFS first of all?
So, sir, like what I can do is I can firstly create a visited vector and initially store all them to zero. That is, all of them are unvisited. So when
Okay,
initially in the queue, I will insert the index of the current cell where I'm in, and from that cell, I will check the all possible moves that can be made, and all the moves they can be made in one, right? So the counter will be incremented by one only itself. So the change will be constant. So for every
okay,
cell, I will again accordingly check that if there is a snake or a ladder present in that cell, and if it takes me back to the cell that I had already visited, then there is no need to check that thing again. Else, I
okay.
will push it back into the queue and proceed accordingly.
So from a particular cell, how many types of moves can you have? Like you mentioned that from a particular cell you will have moves. So how many, like what kind of jumps or what kinds of moves can you have from a particular cell?
So the maximum in this dice throw is six, right? So it can be, I can move six moves like plus one, plus two, plus three, or something. But in case if they are not possible, then we won't consider those moves.
Correct. So normally you are saying that if you are standing at the current cell, then you are saying that current plus 1, current plus 2 up till current plus 6 kind of
Yes, I
thing.
mean accordingly
You
for
can.
accordingly we'll check what are the x and y coordinates. But
Okay, and why are you thinking of using a BFS approach?
it's like in the grid. That's mostly what I do, sir, in this grid or array kind of questions, where the grid is given and the minimum number of moves are asked.
Uh, can you tell us anything special about BFS? Like why we do so?
Mm, I'm generally comfortable with that algorithm, so that's why.
Basically, it's because it's if the edges are not weighted, then it will give you the shortest path, na?
Yes,
Like
that's
shortest,
that's
like
what I,
minimum number of moves, it will give you the answer,
yes. That's
right?
what I'm saying. The
Because
change is
it's
constant, right? It will be incremented by plus one itself. So we just have to
okay.
see that the point where we are going is not yet visited.
So if you want, you can start writing the code and tell us how you will approach further. While you're
Okay.
writing the code, you can explain us as well. So you can do what one thing, you can maximize the screen. There on the top right corner, you will see that there's a full screen option.
Okay.
Yeah,
Just
yeah, there only.
number. Okay. Okay. So initially, all the it is a 5 cross 6 grid, right?
Yes.
5 cross 6. And it is numbered 1, 2, 3, 4, 5, 6 on the bottom.
Uh, s-
So initially,
so
I think I will.
okay. Is the audience in the audience everyone is clear with the question or not? I hope that everyone in the audience is also clear with the question. And for your better understanding, I'll also paste the question link in the chat. So if you want to explore this question, you can open it side by side in another tab if you want. Okay.
So
So if everyone
initially,
is clear, you can hit the like button, guys. Yes, go forward. So you're saying that you will take a map as well. Okay, why are you taking this map?
first, like it will be easier for me to understand that the current cell where I am does it has a snake or a ladder from its beginning. That if this cell contains a ladder to go up or a snake to go down. So for that, first I will store it in a map.
Okay.
So after that,
And why are you doing I plus is equal to 2? Can you tell us about it as well?
what?
Why are you doing I plus is equal to 2? Can you tell us a little bit about it as well?
Sir, it is an array, right? So the first one is the starting element, and another plus one is the end part of it. That is, if it is a ladder, then
So,
the I comma 0 is this. Oh, sorry, wait a minute.
correct.
Why I thought it was a 2 here, so that was a mistake from my part.
Okay. Okay, so you are pushing one into the queue.
So here the one is already visited, and I have pushed Q in this part. So initially the answer will be set to 0. That is the number of moves that required. We haven't made any moves yet. So all the cells that are initially present in the queue, I will pop them all at once first.
Okay.
So this currently is the number of the cell that we are currently in. So from this, firstly that if u already is 30, that is the we have reached, then I will return the number of moves that we have made. Else, if we have not reached the move yet, then we will try all possible moves. And next is equal to
Okay.
u plus I. Now, if next is less than equal to 30, then itself we have to consider this. And the next thing that we have to check, if capital M, if the next contains any snake or ladder pair in it, that is, if it is in beginning, it has the beginning of a mouth of a snake or the base of a ladder. If it is else, we can simply push it. Visit of next, we have already visited next and we have pushed it in the queue. Else, next is equal to capital level, next. And we have to consider this only if it is
So
not
can you
yet visited.
elaborate for us a little bit more about this if condition?
Which condition, sir?
The count condition, map dot count condition that you have written. Can you elaborate it for us? The if condition, if map dot
Uh,
count is equal to 1.
so if in the map I have mapped the beginning, that is the base of the ladder, to the end point, that is the start point to the end point. So if this
And
next, that is,
that can be between a ladder or between a snake, right?
yes,
Correct.
yes,
The starting and the ending point.
but it will accordingly redirect it, right, to whatever point
Yeah.
it needs to go. It will accordingly
So
redirect.
so
So
what so if you will go back to the diagram, like can you just escape okay. So like you can put a cross there. Cut option is there. Okay.
okay,
So you are basically saying that suppose you were standing at 1 and let's say you go to 3, right? So you're saying that if you go
yes,
to 3, then
I have an option to go to
you will not
yes,
stay at 3. You are saying that you will go to 22,
22.
correct?
That's how the game works,
Okay.
right? We directly go to 22.
Okay. Okay, so that is what you are
So
also doing.
yes, and if we go to 21, then we cannot stay at 21, right? We will directly be redirected to 9.
Okay.
So that's what I have done, and here I have redirected it. And if the redirected point is not visited, then only we have to consider the point, else we shouldn't consider it. So once all the points are popped, we should increase it. We should increase the answer by one because we have made a single move here, and we have considered all the different points that we can visit.
Okay.
And there won't be a case, right, where the it cannot be visited.
You need to think about it.
I think if snake exists on the mouth of 30, then I think
Most
should I
probably
return a
you
minus
can
one in
take.
that case?
Maybe you can return a -1, but I think that you will always be reaching there.
Okay. So let me try to check if it works. What is it? Runtime
You're
error.
getting a runtime error.
Why is that so?
So are you iterating on any of the indexes? Like, are you missing a particular condition here?
31. Even in consider that if the next is, I have even considered one based indexing, right? So that shouldn't be a problem. If next is less than equal to 30.
There's one condition that you told, but in the like while the approaching, I'm not sure whether you have explained it or not. Okay.
What's that?
So you talked about a condition that if you suppose you are standing at 29, then you cannot take a jump of 5. Correct? You suppose you are standing at 28, then you cannot take a jump of 4. So have you taken care
Okay,
of these
so
cases as well properly?
yes, I have written it right. If next is clearly less than equal to 30. So this
Okay.
part works. There's no error in this portion. Let me decrement this.
So are you sure that you have written the conditions, if conditions properly?
Yes, I am confident on that part. Oh, okay, okay. There need
Correct.
to
So
be
you
a
were both the conditions need to satisfy. Correct.
yes, yes, yes. There was a or statement there, so both need to be satisfied. Then only you can move. So the three and the expected is also three. So should I try to submit?
Yes, you can submit it. Okay, it gives you a wrong answer. Can you just maximize? There's a maximize button there, no? Just a little bit on the upper side. Yeah. So what answer are you getting? So
So
ideally, the output for this case should be 4, and you are getting the out like okay, you are getting 4, but the output should be 3. So that means you are counting more number of moves.
I have already made that. Let me just check what I'll simply print out what are the vertices that I'm visiting in one particular cycle. Why is it giving me 3? It shouldn't give me 3, it should give me 19. Oh, wait a minute. Is it a 2 times n size array?
Correct.
Why are this was 3 and 3? So let us try the example test case as well.
So you got the error. I told you repetitively that the size is 2 cross n. Na? There are n pairs, and so definitely there will be 2 cross n.
Okay, so it is solved, sir. So that was
So like
simply it. It
you were
was,
missing this condition, na?
yes, it
Basic
was 2
condition. Okay.
cross n basically. So that was the problem.
Okay. Because I told you that there'll be a total number of ladders and the snakes will be n. The total number of ladders and the snake. So basically the number of pairs will be 2 cross n, and that is what I mentioned in the starting only. So you could have just thought about it a bit more, but that's fine.
Okay,
Okay.
okay, okay, sir.
So now I'll move to the next
Uh,
question
sh-
for now.
should I remove my headphones? The battery is, I think, so dropping.
Uh, if you think that that's fine. If you want to use any other thing, you can use.
Okay, okay.
Okay. So you can change your headphones quickly, and then I'll give you another question. So audience is also clear with this question. I hope that everyone must be clear with it. Okay. So now what I'll be doing is I'll be giving you the another question. I'm just waiting for a second. Okay. So can you open the private chat now? So I've been given another question. You can open it. Okay.
This one, right?
S- Yeah, let's have a look at this question as well. So, in this question, what I'll be giving you is, I'll like the problem name is gray code, and what I'll be giving you is like I'll be giving you will be given an integer n. Okay, so I'll just give you an integer n, and according to that, you have to print the gray code for it. Okay, so there is a pattern. So, can you just go to the editor screen so that you can write what I'm telling you? You can just there's you can just go to code. No, not this editorial. Go to the writing like coding screen.
Okay,
Okay,
yeah.
perfect. Put an enter there. Put an enter there. Okay. Now, if n is equal to 1, suppose that n is equal to 1, then what will be the gray code for it? Just put n is equal to 1. Like, just write n is equal to 1. I'll tell you. I'll tell you. Okay. So, just n is equal to 1. If n is equal to 1, then the gray code for it will be 0 and 1. So, just put a space and then write 0 and 1. Okay. So, if n is equal to 1, if n is equal to 1, then the gray code will be 0, 1. Okay. Is that clear?
Okay.
Okay. After that, if n is equal to 2, suppose if n is equal to 2, okay, then what will happen?
So
So it will
basically,
be
for
0, 0.
every bit, we have to try all the possibilities. Like it can be 0, 1, 0,
Uh,
1, 0, 1.
yeah, just write n is equal to 2, then I'll tell you what is happening here. So n is equal to 2 is nothing but 0, 0, 0, 1, 1, 1, and 1, 0.
Okay.
Okay. Now, can you tell me any pattern in the adjacent representation of bits?
So basically, every
Like for
bit has two options, right? So it
no,
can
no, no,
either be set
that
or
that is
unset.
fine. That is fine because we are talking about bit representation, so that is fine. But can you tell me anything about the representation? Or you can see n is equal to 3 also. You can scroll down and see example number 2. If you see n is equal to 3, so can you tell me any pattern? If you
So
will see the pattern, so
for the fourth,
every adjacent pair
yes, that,
differs by only one
extra
bit.
bit, yes.
If you see n is equal to 1, then the adjacent bits 0 and 1 differ by 1 bit only. If you see n is equal to 2, so 0, 0 and 0, 1 differ by 1 bit only. And 0, 1 and 1, 1 also differ by 1 bit only. Then 1, 1 and 1, 0 also differ by 1 bit only. Correct? That is the right bit. If you see n is equal to 3, then for n is equal to 3, you will have 0, 0, like 3 zeros. Then after that, the second one is 0, 0, 1. So they differ by 1 bit. Every pair that you will see here, it differs by 1 bit. Okay, so I'll give you a particular value of n, and that will be within a range. Let's say it can be 15 or 16, something like that. And what you have to do is you have to tell me that, okay, what will be the gray code sequence for it, such that every bit is alternating in this fashion.
Okay.
Like every adjacent pair has only 1 bit different.
Okay, okay.
So is the question clear to the audience as well?
0, 1, 3, 2.
So the question is clear to you, Sarvesh?
Yes, yes. So I mean the bitwise, basically the XOR of adjacent elements should be a power of 2, exact power of 2. That's the whole thing, right?
No, no, that is not the case here. That is not necessary. The necessary thing is that every adjacent pair will be differing by 1 bit only. If you see any pair, like if you see 111 and
Yes, yes.
101
Like,
for n is equal to
okay,
3,
okay. Mhm.
if you can highlight this 111 and 101, so they differ by 1 bit only. If you see 101 and you see 100, like 100, so they differ by 1 bit only. So you have to like you have to put all these representations in an array list or in a vector, and you have to return this final answer for the nth sequence.
Okay.
I'll paste the link, everyone. Just give me a second. I'll paste the link of this question as well. And can you tell me one more thing? Let's say n is equal to 3. So how many elements I'm having? Can you count that?
We have 8 elements.
8 elements. Okay. When n was equal to 2, then how many elements was I having?
4. So I
4.
think it
When
will
n was equal
increase
to 1,
by
then
2's power. 2's power it will
2 to
keep
the power
increasing.
n. So like if you will read the problem statement now, so it will be much more clear to you. You can scroll up. Okay, so it says that you will be given a number n, and you have to generate the bit pattern from 0 to 2 to the power n minus 1. Okay, so basically there will be 2 to the power n n representations for a particular n. Okay, now how will you do it?
Can I think for a bit?
Yes, whatever you are thinking, you can also share your thoughts with us as well. And in the
Okay.
audience also, if they have any approach, some of the people have given their approaches, and I think that's correct also. Other people can also tell us about their approaches.
Second plus another power of 2 which is not yet taken. Another power of 2 which is not yet taken. Should generate.
If you are able to solve this problem, then I'll ask
Sir,
a follow-up question. Yes.
there is one approach that I think. So basically, see, they differ by 1 bit itself. It by default means that for for let's suppose for I, then I plus 1, we add a power of 2 to it, right? Some power of 2 is added to it again. So let's suppose that if we begin from 0, then I can take another, let's suppose 2, I add 2 to it. So for another part, it should contain 2 and plus some another bit and plus some another bit. That's I think how we can generate it. And
Okay. You have to notice that you do not want to return the decimal representation of it. Okay. You
yes, yes,
want to represent
I know it, it
you want
is to
to
be
return them in form of strings.
string. It has to be in string format. Suppose I give it 0,
You can just think about it because you have to return the strings. So how can you generate the strings, and can you take a help of something for generating the strings? You have to think in this direction.
No, the first I'm thinking about how I will arrange this, and once I get a solid this, I will explain how to generate these things.
So what approach is coming to your mind currently?
I'm thinking that there might be some pattern here as to how they can be arranged. As will then we'll keep
So
increase.
so can you guess that pattern by looking at n is equal to 1, n is equal to 2, n is equal to 3 at least? Okay, so
So
what's the difference between n is equal to 1 and n is equal to 2? Any like just think about it. You have written it in on the right side. N is equal to 1 and n is equal to 2. What's the difference between the two?
I think in the first part they have just added one unset bit, and then the it is been I think reversed, and they've zero, zero, one, zero, 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 zero. Take this thing, reverse it. Set it one, zero, zero.
And meanwhile, in the audience, if you like the quality of the questions that we have taken, so all of you can give us a +1 in the chat so that I can understand that you like the questions that we have taken. And please hit the like button, guys. I can see the number of people watching are more compared to the likes. So please hit the like button if you haven't already.
I think I figured out the pattern, sir.
Okay.
So in this case, let's suppose I will explain with n is equal to 2. So the first thing that if you notice that if I add 0 to here, 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 and here, it won't change the answer one bit, right? Next case,
Okay.
that is if I now the current that bit is set, right? This is unset bit. The extra bit that I have added is unset. So in the next case, when will copy
Can
paste
you
it.
write it like you are writing for n is equal to 3? So can you write it for us? Okay.
So in this case, once I have the extra bit in first case it was unset. In the second case, I have the bit is set. So this time we will reverse it basically. We will reverse this thing. While adding, we won't add 100 to 101. We'll reverse this thing. So what we will get is this number. So when I'm transitioning it to 4 from n is equal to 3, this
Can you
same
tell us?
zero.
Can you tell us again, like how you got from n is equal to 2, how you generated n is equal to 3? Can you tell us again by writing n is equal to 2? Then can you tell us how you generated n is equal to 3 once again?
Sir, so the thing that I'm saying is in the first case when n was equal to 2.
Suppose that n was equal to 1. So how can you generate n equal to 2 from n is equal to 1?
Okay, so what I'm telling is basically for this is while I'm writing for n is equal to 2, what I've done is this for n is equal to 2, and this is a reverse of it basically. Okay, am I clear till now?
Can you tell me like how did you like? Can you like see? You are telling me to generate n is equal to 2, n is equal to 3 from n is equal to 2. But can you tell me how will you generate n is equal to 2 from like how will you generate n is equal to 2? Can you tell me that? My question is this now.
Okay, I will first explain that. So for n is equal to 1, this was our base sequence. This is the base sequence, and this is the
Okay.
reverse of it, basically. So
Okay.
I'm adding an extra bit in the first case when it was unset. So for the first half, it shouldn't change anything, right? It is still in the
Okay.
gray code format. So in the second case, I will
Okay.
simply set that thing. So here I have generated n is equal to 2. So
Okay.
while generating n is equal to 3, since the first half still holds to the law, so there is no problem on that front.
Can you also move down in the second, in the left half? Can you scroll up so that we can also see the what is n is equal to 3? You can scroll, you
Uh,
can scroll down basically.
this is n is equal to
Yeah.
3.
Yeah. So first
So
half, what, which,
first half is for n
okay.
is equal to 2, and the second half is simply the reverse of it is appended to it.
Okay.
Now I add an extra bit which is basically unset, and in the next case I'll simply set it. Now since these two
Okay.
are basically the same and only one bit differs, right? Where
Okay.
that it was 0 and now they differ by one bit, and it's the first half and the second half both are already in the gray code format. Only one extra common bit was added to all of them, so it shouldn't violate any property for gray code. And
So
similarly,
can you
while
can you
for
summarize? Okay. So can you
so
summarize how you're
basically,
getting the nth gray code sequence?
so for getting the nth gray code sequence from the n minus 1th gray code sequence, the current sequence, let's suppose it is S, will append the reverse of S, let's suppose it is SR, will append SR to S, and for S, we will attach an extra bit, the unset bit, to the leftmost part of the elements. That is, in this case, let's suppose for n is equal to 4, I copy paste it again, and I will add one extra 0 here to all of them, or extra 1 here to them, and we can basically generate. We can keep generating. Basically, we can keep generating the n minus one
So you're
nth
saying that
sequence.
for the first half you will append a 0, and for the second half you will append a 1.
Yes, yes. So first, if the sequence is S, I will reverse it. I will do SR. I will append both, and an unset bit will be appended to the first half, and a set bit will be appended to the next half.
Okay, so you are saying that for the nth sequence you will take help of what for generating the nth
Let's
sequence? How
suppose
will you use?
the base sequence will be n is equal to 1. Okay.
Okay.
So let's suppose if I am trying to algorithmically explain it, the for the base sequence, let's suppose I will have a vector string previous, which will tell me the sequence in the pre n minus 1th sequence. So while getting the nth sequence, the first thing that I will do is store this sequence. I will append 0 to it and store it in some vector. I will append 1 to it, store it in another vector. I will reverse the first, second vector and append both and store them back to the previous part.
So you can maximize the screen now and start writing code if you are comfortable.
Okay. So vector string previous dot push back. So this is the base case which I am generating. I will push back the 0 and the 1 strings to it. Now if n equal to 1, I don't need to do anything. I already have previous. Okay. So for int I is equal to 2, comma I is less than equal to n, comma I plus plus. So for every increment, so first what I will do is I will add previous. I will copy it to some new vector. Let's suppose I give this as temporary temp. So next, what I will do is I will iterate over all the elements of the temp, comma j plus plus,
Okay.
and for temp of I will attach 0. Will attach 0 to it. Next,
Okay.
what I will do is I will take another vector. Let's suppose I will name it temp2. I will take it previous. I will reverse this vector temp2 dot begin, temp2 dot end. I have reversed the vector, and what I'm going to do is I'm going to append 1 to this thing, temp2 to 1. So I will basically, what I will do is I will take all the elements of the temp2 and append them one by one to the temporary array. J plus plus temp dot pushback temp2 of I, and in the end I will assign the previous vector to temp, the temp to the previous vector, sorry. And just for clarity, let us see the code that the sequence in each iteration, what the sequence is generated. What is it? Oh, sorry, it was.
Yeah, it was string format that you have to return in the end. Still getting some runtime errors.
Oh, why have I given this? I have to be here. So this is the, let's see, custom input. I will give a giant output. Let's suppose 4.
You can maximize the output stream. Yeah. So you're
So this
not,
is so this is the second. This is the third. This is the fourth. This is the, as
but
you
you
can
only have
see.
to get the init.
Yes, sir, that I know. I'm just for clarity purposes. I was showing this thing, and in the end, we have to simply return the previous vector, which contains the answer. So expected it works. Let me simply try for the last element, 16th. So let me submit and see. So yes, it does pass.
Perfect.
So I think so. It was a
Now,
more optimized than the 2 power n solution.
okay. Now there's a follow-up question for this. Okay. So you can do
Okay.
one thing. You can just quickly reset the code there. Just quickly reset it up. Okay. Uh, all right. So just quickly copy n is equal to 2 now.
N is equal to.
2. Just quickly copy it from there. N is equal to 2, copy it from there. Okay. And paste it on the coding screen. Okay. Perfect. So now suppose that instead of asking you, like here what I'm asking is, I'm asking the bit representations indirectly, correct? I'm asking the bit representation of every number, but in terms of strings, basically. But suppose if I ask you about the integer representation, then how will you do that?
It won't change much in the, like I was adding 0, right?
Okay.
So
So suppose n is equal to 1. So for n is equal to 1, what will be the integer outputs that like what will be the decimal numbers that you will give for that? For n is equal
it
to
will
1.
remain. So let me try to finish, right. For n is equal to 1, it will be 0 and 1. But when in n is equal to 2, when I'm doing n is equal to 2, so in the algorithm, when I was adding 1, basically instead of adding 1, I will add a, basically we are adding a power of 2, right? We're adding a power of 2 to it. So this case, it was 2. So 0 and 1. So for 1 and 0, it will be 3 and it will be 2. So when I'm doing the same thing for 3, when I reverse it, I will add 2 to the power this the next one, that is 4 for this thing. So it will be
Correct,
6
because you are because you are
3.
changing the leftmost bit now again, like again and
Yes.
again you
So
are incrementing the leftmost bit.
yes. So it won't change much. It will just be adding a power of 2 to the whole thing. So it will be the same.
Okay, correct. That's great. So this like this was these are the questions that I wanted to ask, and you have also clearly answered the follow-up question for this. Basically, in the follow-up question, I asked him this thing, that suppose you have 0 1, right? So maybe you could have like explained it in a much better manner. But basically, he's saying that like I'm asking him the decimal representation of everything, right? So he's saying, like I'm saying that if n is equal to 1, then the decimal numbers will be 0 1. If n is equal to 2, then the sequence looks like 0 0 0 1 1 1 and 1 0. So what is the corresponding decimal output for it? It's nothing but 0 1 3 and 2. So that is what I'm asking, that for every instead of printing the strings, that is the bit representation, you give me the decimal representation for it. Okay. Then he is saying that if you will observe the first case, so now for n is equal to 1, for n is equal to 1, you have 0 1. Now for n is equal to 2, you have the first part as the same, and the second part is nothing but 1 1 and 1 0. That is nothing but opposite of 1 and 0, and you are adding 2 to it. Okay, yes, that is what you are saying, correct?
Yes, yes,
And every time your power is increasing. Okay,
yes. The
so
power of
that is great. So now before I give you any feedback, so like can you tell us your experience about this mock interview?
So it was a pretty unique one. I've never given a mock interview before, and I think it really simulated the whole interview process. I mean, the when it matter when you get stuck, but the interview is still going, so you have to keep communicating, keep getting your thoughts on the other end. So I'm not saying that I was entirely polished in a manner, but I think this will clearly help me in upping my skills and be better in a
Okay.
proper interview.
uh, so do you want a feedback from me?
Yes, I will definitely like a feedback.
Okay, so before I give a feedback, so in the audience, for those who have liked this interview, for those for those people who think that these questions were a little bit new to them, maybe they can be easy or difficult depending on your practice. But if you have like if you like this, then all of you can give us a +1 and hit the like button as well, guys. Now coming to the feedback for you, Sarvesh. So I think in the first question, I told you a lot about this thing about the array size, that is 2 cross n, but you did not
Yes, yes,
think about it while writing the code. So those were some mistakes that you were doing. And also when you are in an interview, here I have given you a compiler, right? Suppose if I was doing this with you on a Google Doc, so if I was doing the interview with you on a Google Doc, that generally companies like Google or other companies might do. So in that case, you will not be able to see the error by running the code. Okay. And so this is one thing,
okay,
like you should have thought a bit more before directly compiling and testing the code. Here you
yes,
had a compiler, so I allowed you to do the compile and run thing, but you will not be always allowed this thing, so you can just think about it a bit more. And another thing is like you can explain the things a bit more better, like when I asked you like why you are using BFS, so you said that I have been using it for some long time, but you could
yes,
have
yes.
come up
That
with the approach
that
that
was
okay,
not a problem.
what is the benefit of BFS compared to DFS and stuff. You could have told that okay, it gives you the shortest thing and everything like that, whatever
That's what
the
I'm saying. That, it comes with the practice, right? So if you
yeah. So you I know that you knew this thing, that BFS will give you the minimum dice throws, but you could have told us about it a bit more, right? So that was one another thing. And in this question also, you were writing the code very smoothly, but still you did not explain it very much. So another thing is that you could have explained it a little bit more, and maybe you could have made it a little bit more readable as well. And you have written it in iterative manner, that's really great. But you could have also told that you could have done it using recursion. Okay, you can do this question using recursion as well, so you could have told about it as well. And there was another approach, like bit set approach is also there, in which the like in this case your time space complexity is order of 2 to the power n minus 1, but you could have used a bit set as well, so that will also improve your space complexity. So you did not tell about the recursive approach and the bit set approach, so maybe you could have thought a little bit more about it as well. But these are the feedbacks. But overall it was a good interview, and I liked interviewing you. Maybe you'll improve with time as well. So I wish you all the best for the placements. And in the audience also, you can just give us a +1 in the chat before we go, and hit the like button as well. And thank you, Sarvesh, for joining for this mock interview and giving us your precious time. So thanks a lot, Sarvesh.
yes, yes,
Do you have
yes.
anything else to say about this interview?
No, sir, nothing.
Okay. So thank you, Sarvesh. Now, coming back to the audience. So thanks a lot, everyone, for coming to this live mock interview. And again, I would like to remind you that if there's any one of you who wants to give the mock interviews live with GFG, so you can see down there in the description of this video, there will be a Google form attached for the live mock interviews. So you can fill that form, and our team will reach out to you for the mock interview based on your schedule. So you can make sure to do that. And someone is talking about the question link for you, so you can Google it out. You will get that link also. The gray code part 2, the follow-up question, for that also you'll get the link, Chetan. Okay, please bring more such interviews. Yes, definitely, Shlok. We'll try to bring more such interviews. Okay. So thank you everyone for joining this, and make sure to hit the like button and comment down helpful or a +1 if this interview was helpful for you. And thank you everyone for joining, and have a great day. And make sure to keep practicing, keep coding, guys. Thank you for joining.